Hi, welcome once again to Weekly Physics and CSZC with Sir Danny. Today I'm going to show you how to break down vectors into different components, such as the x component and the y component, also known as the horizontal and the vertical components. Before going to breaking down vectors into different components, let's first have a quick recap on what is a scalar and a vector. A scalar is a physical quantity that contains magnitude alone, but vector is a physical quantity that contains both magnitude and direction. Here are some examples of a scalar: distance, speed, and mass. And here are some examples for vectors: displacement, velocity, and weight. Now let us take a closer look on the difference between a vector and a scalar through the different examples that I provided. If you talk about speed, we are just talking or measuring how fast a certain object is moving. But if we're going to talk about velocity, this is determining the rate of change of a certain object movement. Again, it is all about how fast is the change of a certain object's movement from one point to another point. But if you take a closer look, speed and velocity have the same unit, the unit of meter per second. Any vector has two components, but the question is, what are these two components and how are we going to break it down? A vector that lies along a Cartesian plane is comprised of two different components, such as the x and the y components, and these components are perpendicular to each other. And how are we going to determine these components is by using the basic trigonometric functions. It's also dubbed as SO, Ka, TOA. But I have here presented to you a derived equation for different x and the y components. The x component is derived as v sub x is equal to v cosine theta, and for the y component, it is v sub y is equal to v sine theta. The v here stands for the measurement of the vector, while theta is the angle between the x and the y axis where the vector lies along. I have here an example of a vector which is equal to 40 meters per second and directed at 20 degrees. Also, I have illustrated how the vector would look like in a Cartesian plane, and notice that the vector lies between x and y at 20 degrees as our angle theta. The question would be now is, how are we going to break down 40 meters per second into different components, the x and the y component? What we can do here is that we need first to illustrate the different x and the y components using the tip-to-tail method. First is, we need to draw a vector. I will be using a broken line to denote that this vector is only a component. The horizontal arrow would signify that this is the horizontal component, and the vertical arrow will signify that this is the vertical component. Notice that we have formed a right triangle. And to determine the values of x and y components is by employing the three basic trigonometric functions, which is equal to SO, Ka, and TOA. Notice that the SO, or sine theta, is equal to the opposite side all over the hypotenuse side, and the cosine theta is equal to the adjacent side all over the hypotenuse side, and the tangent theta is equal to the opposite side all over adjacent side. Now, which among the three basic trigonometric functions is more appropriate in finding out the x and the y components of a vector. We have here an illustration and its equation. If we take a closer look, the x here is the adjacent side and the y is the opposite side using the perspective of our angle theta. Hence, we have here, we can use cosine theta for the x-axis, which is equal to cosine theta. We can write this as cosine theta is equal to adjacent side all over hypotenuse, which can be transformed in a vector form as x, or I'm more comfortable using v sub x or v sub ox to deter that this v sub ox as the vertical component of a certain object, of a certain vector, and all over hypotenuse, which can be written as v sub o. And the same thing that would happen for the sine for the y-axis, or for the y component, is sine theta, which is equal to the opposite all over hypotenuse, which can be written in a vector form as v sub oy all over v sub o. Then what can we do here is that we can substitute the values for v sub o and cosine theta. We can write here cosine theta, the theta now would be equal to 20, is equal to v sub ox all over 40 meters per second, and sine 20 is equal to v sub oy all over 40 meters per second. Now, I want that v sub ox and v sub oy will remain on that side of the equation, but the 40 meters will be transferred to the other side of the equation. How can I do that? Is by multiplying both sides by 40 meters per second. If we write down here cosine 20 is equal to v sub ox all over 40 and multiply both sides by 40, the 40 here will be cancelled out because we're going to divide them, and if we divide 40 by 40, the quotient will be equal to 1, and any number multiplied by 1 will result to the same number. So then we can write here as Vox is equal to 40 meters per second cosine 20. The same thing that will happen to y. If we multiply both sides by 40, sine 20 the 40 on this side of the equation will cancel out because it's equal to 1, and then we can write this as Voy is equal to 40 meters per second sine 20 degrees. And then we can simplify this as 40 meters per second cosine 20 will give us 37 meters, while 40 meters sine 20 will give us 13 meters.